For over 100 million years, they ruled the Earth, the largest creatures that ever lived. And then suddenly, mysteriously, they disappeared. A force even greater than the great dinosaurs may have wiped them out in a single stroke. Now, in one of the most intriguing stories in science, researchers are finding clues that link the disappearance of these great beasts to events in space. The trail of discovery begins on a hillside behind an ancient Roman town and leads halfway around the world to the Badlands of Montana. Armed with new tools and ideas, scientists are seeing the unseen. Electron microscopes have opened the door to the infinite world of the very small. Computers sift and organize the fossil record. And great telescopes probe the far reaches of our solar system as one scientist searches for what he calls Nemesis, the Death Star. It is a search that one day may reveal the future of planet Earth. On a battered moon lies the evidence of a force that shaped our planet. Beneath the hostile clouds of Venus may be the landscape of a primitive Earth. The red planet, Mars. Upon it lies the evidence of gigantic floods that once scoured its surface.
We cleared the tower.
Join us now on a voyage of discovery to the edge of the solar system and to strange new worlds that hold the secrets of our own creation. The story of planet Earth begins in space.
Major funding for this program is provided by the Annenberg CPB project. Corporate funding for Planet Earth is provided by IBM. IBM is proud to support the innovative spirit of scientific inquiry that made this series possible.
The Allen Hills of Antarctica, one of the most forbidding places on Earth. An unlikely setting in which to begin the exploration of our solar system. But in these bleak ice fields are clues to its earliest history. In bone-shattering cold and winds that reach 100 miles per hour, bands of scientists camp here each brief Antarctic summer. They come to scour the ice for meteorites, fragments of the solar system that have fallen to Earth. Meteorites are trapped in a huge conveyor belt of ice and carried from the heart of the continent toward the sea. As the Allen Hills block the flowing ice and allow wind to wear it away, meteorites migrate to the surface. These tiny lumps were created by the same tumultuous processes that created the sun and planets. They are cosmic time capsules. Preserved in this colossal freezer, they tell a tale as old as the Earth itself. By analyzing this ancient material, scientists can reconstruct the events that created our solar system. Some 4.5 billion years ago, near the outer reaches of the Milky Way, a huge cloud of gas and dust begins to condense. Billions of miles across, the cloud collapses into a flat spinning disk, a solar nebula. Within the disk, particles collide and adhere, and the primordial sun and planets struggle to emerge. As the sun ignites, it blows away most of the gas from the inner solar system, and only hot, rocky worlds remain. Enormous collisions shaped the planet we will one day call Earth. Perhaps one last immense impact spins off matter that will become the moon. The Earth begins its slow transformation into the planet on which we live today. Four and a half billion years later, the Earth is still evolving. We inhabit a restless, shifting planet whose surface changes in endless cycles of creation and destruction. Most of the Earth's history is preserved in its rocks, but vast chapters are missing. The very earliest rocks, from Earth's first billion years, are gone, destroyed by its incessant activity. How can we know what happened on Earth before its restless geology erased the record? Our nearest neighbor in space was shaped by the same events that made the infant Earth. Might our long-dead moon hold the secret of Earth's missing history?
But if I were to say, my fellow citizens, that we shall send to the moon 240,000 miles away a giant rocket made of new metal alloys, some of which have not yet been invented, capable of standing heat and stresses several times more than have ever been experienced, fitted together with a precision better than the finest watch, carrying all the equipment needed for propulsion, guidance, control, communications, on an untried mission to an unknown celestial body, and do all this and do it right.
July 20th, 1969. Apollo 11 relays live pictures from the moon. Craters glide by. Are they extinct volcanoes? Or wounds left by still more violent events in the distant past? Ironically, part of the answer lies in rare moon-like regions of the Earth itself. It is not easy to see craters on Earth. Most are so eroded that only faint circular scars remain. But how were these strange structures formed? The mystery was solved here at Meteor Crater near Flagstaff, Arizona. A mile across and 600 feet deep, this enormous hole was created 50,000 years ago in an event of unimaginable force. Many scientists believe that Meteor Crater was the remnant of an old volcano. The real explanation involves a more radical idea, that bodies from space helped shape the Earth. Gene Shoemaker, a scientist with the U.S. Geological Survey, helped prove that the crater formed when a nickel-iron meteorite blazed through the skies and smashed into the Earth. The evidence was all around.
Well, the main evidence for the impact origin of this crater is in the geology. Some of it's right here underneath our feet, where there's a deep lens, 600 feet deep, of broken rock that was explored near the turn of the century by Daniel Moreau Beringer and his associates. And what we find is a deep lens of broken rock going to that depth, with the lower 50 feet containing the melted droplets of the meteorite, now frozen in shock-melted rock. Another part of the evidence we can see straight away in the crater walls up here. We can see the rocks are actually offset along a large fault. One side of the crater wall has been peeled out much further than the other side. The rocks that were once here in the middle of the crater were thrown out in the shock wave and spewed out like the petals of a flower blossoming and just laid out on the surrounding terrain as a giant blanket of broken material.
Collisions with Earth are extremely rare. So, to study their role in the formation of planets, scientists invent ways to make their own. Planetary geologist Pete Schultz and his colleagues at the NASA Ames Research Facility near San Francisco perform unique experiments to demonstrate what happens when a body from outer space strikes the surface of a planet. With an instrument called a vertical gas gun, they reconstruct these great collisions.
The 400 frames per second up here.
Right.
And we've got an 8,500 frames per second nova on the side.
A vacuum is produced to simulate conditions in space. Then explosions are recorded in extreme slow motion.
200 frames per second with the 2000.
Good. So we should be pretty well set.
At 25,000 miles an hour, the gun fires metal pellets down a barrel more than 3 stories long.
Okay, Earl, let's shoot it. Let's take a look and see what we've got. This sequence shows the crater as it grows. It grows in a very orderly process. It's not chaotic. And under a vacuum condition, there's nothing to interact. And we can see the ejecta curtain simply move out as a wall of debris. Very early times, this wall of debris actually has the ejecta moving upward and outward. At later times, that ejecta is moving downward and outward. But the net effect is still this wall of advancing material. You can see that the ejecta curtain moves or turns into clumps. And these clumps eventually will impact the surface as it moves outward in this very orderly process.
In miniature, these experiments recreate the impact craters we see on the moon.
Well, here's the crater. Now, this is the edge of the target. We find the crater right in the center, and we find a very nice symmetrical rim. As we go away from the crater, the ejecta, the material tossed out by the crater, thins with distance. If we step back, we find that we have clumps or rays of material. We saw that in the films. We saw the ejecta curtain breaking into the clumps and then impacting the surface. And this is what makes up the crater rays that we see on the moon.
These experiments reveal the forces that left thousands of craters and their explosive rays on the moon. Yet to read its real history, we have to know when the bombardments took place. And the moon's dark plains and ragged mountains, when were they formed? Until man walked on the moon, no one knew.
Fantastic. Perfect precision is Planet 1 on the Plains-a-Day card.
Roger, we copy.
What a neat place. The roller is running, Houston. We tried through a few of these little craters.
As astronauts roam the moon's surface, their most important task is to gather samples of rock.
Look at the size of that rock. We can see. The closer I get to it, the bigger it is.
Most scientists believed that the moon's rocks would be ancient. Dating the lunar surface would finally reveal the early history of both the moon and Earth. They were wrong. Most moon rocks were between 3 and 4 billion years old, much older than those on the geologically more active Earth. But still, some 500 million years of the moon's history was missing.
Good guess.
The samples gathered so carefully were not part of the moon's original surface after all. It too had vanished like the Earth's in the remote past.
He did it.
As more samples were returned, the early chapters of the moon's history began to emerge. 4.5 billion years ago, the initial formation of the moon is complete. Its surface, heated by repeated impacts, cools. "4 billion years ago, a second massive bombardment may have occurred, destroying much of the original surface rock. For millions of years, lava wells up through the crater floors, hiding still more of the original surface. 3 billion years ago, the moon's surface solidifies. Except for a slow rain of impacts from space, it remains unchanged today. Our journey to the moon provided a surprise. Bombardments in space are not occasional catastrophes, but the most important force in the formation of planets. To Gene Shoemaker, Meteor Crater reminds us that impacts once helped shape the Earth as well.
On the Earth today, other processes are more important, so that impact craters are a rather inconspicuous feature of our landscape. But on the Moon, on Mercury, on Mars, on some of the satellites of Jupiter and the satellites of Saturn, impact craters are still the dominant feature of the landscape and the dominant part of the geology.
To explore these neighboring planets, we developed even more fabulous machines. Robots, sophisticated enough to travel millions of miles, were built. To scrutinize the worlds beyond, to land upon them, and to report upon what they found. The first planet we would visit was Venus. For millennia, man has seen Venus as a bright star glimmering on the horizon. Until recently, it resisted exploration. Scientists know Venus as our sister planet, nearly the same size and weight as Earth. Still, it remained a puzzle enshrouded in a mantle of clouds. Our voyages revealed it to be a most un-Earth-like place. If we could descend through the dense atmosphere of Venus, we would find it filled with carbon dioxide, racked by storms and bolts of lightning. Unlike the billowy white clouds of Earth, those on Venus are thick and poisonous, filled with sulfur and sulfur droplets, an acid rain capable of dissolving the hardest of metals. At some levels, winds up to 200 miles an hour whip the clouds around the planet. And on the surface, the immense atmosphere creates a pressure 90 times more crushing than on Earth. No place can replicate the climate of Venus. No other world is as scorched and barren. No other landscape so charred and seared. But Death Valley on a hot afternoon can give us an idea. Venus has evolved very differently from Earth. How did it become the hot, desolate planet it is today? Jim Head, a planetary scientist at Brown University, is an authority on Venus.
Here in Death Valley, we find ourselves in one of the hottest places on the Earth. But it's nowhere near as hot as it is on the surface of Venus. Even though temperatures here in Death Valley on a really hot day can exceed 120 degrees Fahrenheit, on Venus, they get up regularly to 900 degrees Fahrenheit. In fact, it's hot enough on the surface of Venus to melt lead. How did it get this way? You might think it was because Venus, in fact, is closer to the sun than the Earth is, but it's only part of the answer. On Earth, the heat that comes into the surface can actually be re-radiated out to space again. On the other hand, on Venus, the very dense, thick atmosphere acts as an incredible greenhouse, a global greenhouse, which traps the heat underneath the surface of the cloud layer and builds up the heat over time.
Only the Soviet Union has successfully landed probes on the surface of Venus. Before they were destroyed in the hostile atmosphere, they radioed back images of a strange and hellish world. The pictures are extraordinary, but they tell us little about the geography of Venus. In 1977, America's Pioneer Venus spacecraft used radar to pierce the dense clouds, and Jim Head and his colleagues had a global view of the planet.
Now, the Pioneer Venus spacecraft provided information from an orbiter, which, using radar instruments, was able to provide a global topographic map of the surface of Venus. We can color the blues lowlands areas, as shown here. We can then color intermediate plains in greens and highlands in yellows and browns and reds. When we look at this now, we can get a much better idea of the three-dimensional nature of the altitudes. And from this, we can begin to see areas such as lowland areas here that are like ocean basins on the Earth in terms of the low area, but of course, because of the heat on Venus, don't have any water in them at the present time. We can also see some very distinctive highland regions. Ishtar Terra here is about the size of Australia and has some very distinctive linear mountain ranges. This one, Maxwell Montes, rises some 30,000 feet above the mean radius, which is higher than Mount Everest is on the Earth.
But even these pictures are inadequate. Much of the Earth's geology would remain hidden if it were depicted in the same way.
Now, this is really interesting because all the familiar features, North and South America and Australia and the ocean basins, really look dramatically familiar. But when we look in more detail, we realize we have the same problem. The resolution isn't good enough to understand the nature of the geology. Something as dramatic as the Grand Canyon is just simply not visible at this resolution. So one of the obvious things is that we can really get a picture of the geography of Venus using the Pioneer Venus information, but we really have no idea what the geological origin of the surface features are.
To study the forces that shaped Venus, Jim Head and his colleagues use a very special tool. High in the Puerto Rican mountains near Arecibo rests the largest radio telescope on Earth. 1,000 feet across, this giant radar antenna bounces signals off the distant surface of Venus and scoops up the faint echoes that return.
The Arecibo data gives us 50 to 100 times better resolution than the Pioneer Venus information. And you can see what the effect of this is by looking at Beta Regio here and outlining on it an area that we will see using the higher resolution Arecibo data.
Across 26 million miles of space, Arecibo senses details down to a single kilometer. At close range, Venus is still more astonishing.
Now, instead of a series of really vivid colors, what we see here is a lot of detail, which is really exciting because we can see right in the middle of the valley a whole series of bright lines which probably represent faults and a large circular structure down here which has arms leading away from it. Now, let's look at these in even more detail, particularly the area to the north. And we can see a lot of faults all the way through the middle of this extensive trough. This is very much like the setting in the East African Rift on Earth, where extensional forces are pulling the crust apart and faulting it into a deep valley. If we look to the south, we see that the circular feature is even more dramatic. It is a volcano which is built up on top of the faults, filling in the valley and sending lava flows extending away from the valley down the sides of the structure. So we can see here extensional tectonic forces, much like we see on the Earth, and volcanism associated with this extension, much like Mount Kilimanjaro is associated with the East African Rift on the Earth.
For billions of years, Earth has been changing. The process called plate tectonics is restlessly rearranging its surface, shifting its crust around the planet. But how did the process begin? Curiously, Venus may hold the answer. Looking at Venus may be a way of looking back across time at the Earth before the beginning of plate tectonics. Samples collected there may tell us even more. In a 5 billion-year-old Venus, we may be looking at a 2 billion-year-old Earth, an Earth as it was in its youth. Beyond Venus lies the red planet, Mars. Just 1/3 the size of Earth, the atmosphere of Mars is so thin it is barely there at all. The Mariner and Viking spacecraft revealed a world upon whose surface was written a violent and restless past. Across the Martian equator, they found an enormous gash, the Valles Marineris. 2 miles deep, it stretches the length of the United States and could swallow scores of Grand Canyons. Nothing quite like it had been seen anywhere in the solar system. Only in our imagination can we sweep through these great canyons, but future spacecraft almost certainly will. To the northwest of the Valles Marineris, Mariner 9 photographed an immense volcano rising 3 times the height of Mount Everest. 17 miles from surface to summit, it has a base as broad as the state of Montana, a place so majestic it is named Mount Olympus. Clearly, Mars is a world that works on a gigantic scale. We Earthlings have always found Mars intriguing. even before we sent probes to investigate. A century ago, we could only view it from observatories like this in the hills of Flagstaff, Arizona. But we speculated it might not be a planet too different from our own. We nurtured the ultimate hope that Mars, too, harbored intelligent life. Toby Owen is a scientist who studies the atmosphere of Mars.
Of all of the other planets, Mars is the one most often imagined to be capable of supporting some form of life. This is a book of drawings of Mars made by Percival Lowell, who built this entire observatory about 100 years ago so that he could study this planet in great detail.
Lowell described a world that fired the public imagination. Through his telescope, he made amazing observations. Each year, he watched the planet's ice caps wax and wane. During the Martian summer, he observed dark areas spread across the face of the red planet. These, he proclaimed, were the blossomings of Martian forests. Carefully, he recorded these changes in his notebooks. Vegetation was not the only kind of life Lowell saw on Mars. He believed it was the home of a desperate and dying race, one that had built a vast network of canals to carry water from its polar ice caps to the parched cities at its equator. As proof, he mapped an intricate system of Martian aqueducts and predicted that one day we would find the inhabitants of an ancient civilization. That is not how things turned out.
This is the telescope that Percival Lowell used to make his observations of Mars, the one through which he looked to make the drawings. Lowell was trapped on the Earth, as all astronomers were, until we learned how to send spacecraft to the other planets. When we finally got to Mars with the Viking project, we found a planet very different from the one that Lowell had imagined. No evidence of canals, no canal builders, no evidence of life of any kind. To get a feeling for what Mars is like today, you might think of yourself being there on a camping expedition, and your job is to try to make a fire and boil an egg. The first thing you discover is that there's no fuel on Mars. There's nothing on the surface of the planet that will burn, not only no life, no organic material. The second thing you discover is that even if there were fuel, it wouldn't burn, because there's only a tiny trace of oxygen in the Martian atmosphere. So that's Mars as we find it now. A dry, cold, desert-like planet with no possibility for life as we know it to exist there.
From the pictures the Viking landers returned, it is not difficult to understand why we found nothing living on Mars. But photographs taken high above the planet reveal a different world. Locked in the ice caps of Mars are oceans of water, and once that water flowed across the Martian surface. Remnants of ancient riverbeds clearly reach out in fine finger-like patterns. And great scoured regions that resemble floodplains speak of a time when Mars was not always so desolate and cold. What could have created these strange features? The first clue came from Earth. The scablands of central Washington state. 13,000 years ago, a 3,000 square mile lake covered much of Montana until it burst its glacial dam and roared across the scablands. A wall of water 30 stories high exploded toward the Pacific to devastate everything in its path. In its wake, it left one of the strangest geological formations on Earth. Like great scars upon the skin of planet Earth, the scablands remain, proof of the power unleashed by a catastrophic flood. Normally, these canyons and buttes would take millions of years to form. The flood gouged them out in less than a single week. From high above, the scars left by the Great Flood on Earth are astonishingly similar to the bizarre terrain of Mars. Billions of years ago, in flash floods that dwarfed those on Earth, liquid water must have rushed over the surface of Mars. Perhaps in the distant past, it was a planet much more like our own. If water was present on Mars, it may have harbored life. Toby Owen believes that once Mars had a much warmer climate and held liquid water. It would have had a much thicker atmosphere, a blanket of gases to trap heat, just as the atmosphere of Earth does today.
That atmosphere would have been rich in carbon dioxide, which is a very good gas for holding heat in once a planet gets warmed up. It would have exerted enough pressure, just about twice as much as we're experiencing right now, to allow liquid water to exist on the surface. So you have a warm temperature, a high pressure, liquid water, and of course the gases in the atmosphere provide you with the elements that you need to get life started. We have all the basic conditions that life would need to begin on Mars. The only question is, did it happen and what did it produce?
In Shark Bay in Western Australia, there are clues to what life on Mars may have been like. Here, organisms similar to those that flourished everywhere on Earth 3 billion years ago still live. They are stromatolites, rocky domes built by microbial communities. For more than 1 billion years, they were the dominant form of life on our planet. If Martians ever existed, they very possibly looked like this. But Mars lost its atmosphere and its water. The planet froze, and the thread of life would have been broken. Percival Lowell's desperate race of canal builders never did rule Mars, but if ever there was life on the planet, it was no less doomed. Mars is the last of the rocky Earth-like planets. Far beyond it is an entirely different kind of solar system. In 1977, the Voyager spacecraft set out on a grand tour of these strange, faraway worlds. 400 million miles from home, the first stop is Jupiter, a huge vaporous planet of gas. A remarkable infrared picture reveals Jupiter as never before. With no solid surface, it continually radiates heat from its core. Had it been several times larger, it would have ignited to become a second sun. 300 times more massive than the Earth, Jupiter spins almost 3 times as fast. Images radioed back by Voyager are computer-enhanced to reveal curious patterns that cover Jupiter's surface. The Jovian atmosphere is filled with clouds that twist and turn in 1,000 shapes. Huge anticyclones disrupt the planet. The largest is the Great Red Spot, big enough to swallow 3 Earths. Sped up, the tireless activity of Jupiter's turbulent atmosphere comes to life. Countless storms are driven by heat from deep within the planet. Around Jupiter orbits a bizarre system of moons. Each holds surprises for the scientists who first see them. Callisto is scarred by giant impacts that have left concentric patterns of rings across its icy surface. Ganymede is the largest of Jupiter's moons. Unlike our own moon, much of its mass consists of water ice. Europa is the brightest of the moons. Its brilliant cracked surface is covered with a smooth layer of ice. As Voyager photographs Io, one of the strangest stories of the mission begins to unfold. What caused the markings on this oddly mottled world? At the Jet Propulsion Laboratory in Pasadena, Torrance Johnson is a member of the Voyager's imaging team.
As we got closer and closer to Jupiter, Io began to look stranger and stranger to us. The picture you see on the screen here is more or less typical of what we saw in the last couple of weeks before encounter. We thought we'd start seeing very large impact basins, craters such as we've seen on the Moon, Mercury, and Mars. We could see strange markings, but no signs of craters. We couldn't, when we were actually looking at these pictures in real time, fully interpret what we were seeing. But what we did know is that we were looking at a geologically very young surface, and that the surface must be renewing or resurfacing itself in some manner.
This image, made for spacecraft navigation, supplies the first tantalizing clue. When it is enlarged and enhanced, a faint smudge appears over Io's limb. Voyager has captured a volcano in action, the first ever seen outside the Earth. Voyager uncovers how the eruptions are produced. Io's volcanoes consist of hot sulfur compounds that explode at hundreds of miles an hour. Towering plumes rise 200 miles above its surface. As it flies by, Voyager captures 8 more active volcanoes. Seen in these remarkable pictures from space, Io is riddled with clear evidence of multiple eruptions. Huge volcanic craters dot its surface. Giant lakes of molten sulfur present a look of decay and disease. Io is a tortured world. Caught between the gravitational fields of Jupiter and Europa, it is constantly stretched and squeezed. As heat from inside escapes, the moon literally turns itself inside out. 500 million miles beyond Jupiter, Voyager encounters Saturn, another astonishing world. Saturn's greatest glory is its intricate system of rings. More than 100,000 miles wide, they may be less than 100 yards thick. The 3 main rings seen from Earth prove to include a dazzling array of ringlets within the rings. One day they may help us better understand those forces that shape the disk from which the solar system itself was formed. Beyond Saturn are still other worlds. Icy Uranus with its peculiar upright rings, and Neptune with its moon Triton, colder, more mysterious, and more distant still. Eventually, Voyager leaves all the planets behind. Beyond the last outpost of our solar system is the Oort cloud, a shell of cosmic debris that remained after the planets were formed. The Oort cloud, where comets reside. Unexpectedly, the debris from this faraway place may have profound effects upon planet Earth. From afar, Earth seems not so different from the worlds around it. Yet our journeys to other worlds have shown us that of all the planets in the solar system, planet Earth is unique. Blessed by its distance from the sun, our planet has become a great blue oasis in the solar system. Like no other world, it is awash with oceans of liquid water. Its air is rich with oxygen, and for billions of years, its temperatures have remained constant. It is a stage upon which geology and chemistry have worked amazing miracles. 3.5 billion years ago, the Earth produced life. From the humblest beginnings, life has grown, spread, and evolved. Tenaciously, it has filled every nook and cranny on the planet. Yet the bewildering variety of life has undergone immense change. Species that now roam the Earth have not always been here. Evolution favors the fittest. Thousands and thousands of families of animals have come and thrived, and then disappeared. But even here, events in space may play a part. This quarry in Utah contains an entire hillside filled with the remains of huge creatures that once lived and breathed. and now are gone. Dinosaurs once lived here, the largest and most spectacular animals ever to walk the planet. For 100 million years, they dominated the Earth. Then, 65 million years ago, the last of the dinosaurs vanished. Only their bones remain. The disappearance of the dinosaurs and the creatures that lived with them is one of the great mysteries of science. Now a new theory links the death of the giant beasts with events in outer space. The story begins half a world away. In central Italy lies the little medieval town of Gubbio, an unlikely setting for one of the most exciting scientific detective stories of modern times. Gubbio is not so very different from any other tiny hill town. The faces that gaze upon its ancient streets today mirror those that gazed here generations ago. To its people, Gubbio is still a good place to work and to play. Yet clues found here may lead to a scientific breakthrough. Containing elements of chance and of brilliant insight, much of the story is still fiercely debated as scientists weigh the evidence and test alternate ideas. The clues come from a nearby gorge containing limestone rock laid down during the Cretaceous era, when dinosaurs lived on Earth. In 1975, Walter Alvarez, a geologist from Berkeley, notices a thin layer of dark clay embedded in the rock just at the Cretaceous Tertiary boundary, that time when the last dinosaurs disappeared. The mystery begins to unravel when Walter shows the clay to his father, Nobel Prize-winning physicist Louis Alvarez.
Well, this is the clay layer that we found, and at first glance it looks like a fairly ordinary little half-inch of clay, but it turns out to be quite remarkable because it falls between the highest bed of the Cretaceous, which is the time during which the dinosaurs were living, and the first bed of the Tertiary, which was deposited after the dinosaurs were gone. And this represents a very small period of time. We now think that this clay layer represents only about a year, but what got the whole project started was the question of how long it took to deposit that clay layer.
I had an idea which turned out later to have been an old idea, and that was the fact that when meteorites come into the atmosphere, most of them burn up. They're shooting stars. When they burn up, they turn into meteoric dust, and the dust settles down on the surface of the Earth. So it's just as though you went around with a salt shaker and shook meteoric dust all over the Earth at a certain constant rate. And so the basic idea was that you could tell how fast the rocks were laid down, or how fast the clay layer was laid down, by observing how much of this special kind of salt, if you want. Salt was sprinkled all over the Earth by the meteoric dust coming down.
Measuring how much dust the clay contains would reveal how long the clay had taken to form. But when the clay at Gubbio is tested for iridium, a rare metal found in the cosmic dust, the results startle everyone. It contains far more than a steady rain of dust from space can explain.
So eventually we came to the firm conclusion that it was an impact from a big chunk of solar system material, either an asteroid or a comet. And that threw up a big cloud of dust, blacked out the light, made it very cold, probably. We weren't sure of that, but a whole lot of terrible things would happen if all that dust came down through the atmosphere.
If Louis Alvarez is right, the dinosaurs met their end in a cosmic collision. Dust thrown high above the atmosphere rapidly circled the Earth. Sunlight was blocked, and day was turned to perpetual night. In the cold and the dark, the dinosaurs and 3/4 of all living species became extinct. As the dust slowly cleared, it formed the clay layer and revealed the desolate face of a devastated Earth. It's an elegant idea, but is it true? The same clay layer has now been found in dozens of sites. But might it have come from volcanic activity here on Earth? Bruce Bohor, a geologist with the U.S. Geological Survey and an authority on volcanic clays, decides to investigate for himself. Bohor knows these rocks at Brownie Butte, Montana, contain pollen and spores from plants that lived with the last of the dinosaurs. Using them as a guide, he quickly unearths the Cretaceous-Tertiary boundary, the time when the dinosaurs disappeared.
The lowest rock that we've exposed here is a dark carbonaceous shale, which is the last of the Cretaceous sediments. We know that from the pollen and spores. On top of that is this pink layer, which is the fallout layer. Over that is a thin coal streak. We know that the plants changed drastically across this boundary here marked by the clay. When we found this clay and dug it out, it looked quite a bit different than the ordinary volcanic ashes that we've been finding. It was harder, it was pinker, it was much finer grained, and these reasons, plus the location at the approximate Cretaceous-Tertiary boundary, led us to believe that it was something special.
Under an electron microscope, Bohor examines fragments of the clay. Treating them with acid, he notices that particles of quartz remain. The particles contain the clue he is searching for.
Well, this is a normal appearing quartz grain, one that you might see from any sedimentary rock or igneous rock or volcanic. It shows no particular features on the surface. It's fairly smooth. But let's look around in the sample and see what else we can find. Now here we have a quartz grain that shows some unusual features. These grooves were apparently formed by the hydrofluoric acid that we used in etching the grains. We had never seen anything like these features on these quartz grains throughout examination of thousands of rocks of various types. We went to the literature and found out that other people had seen something like this, but only at the sites of known impacts of meteorites upon the Earth or at the sites of nuclear explosions.
So the quartz in the clay was formed by an impact, too. It convinces Bohor that 65 million years ago, an enormous impact shook the Earth. But have these visitors from space devastated the Earth more than once? The story moves on. At the University of Chicago, Jack Sepkowski has found another twist to this intriguing tale. He is compiling a list of the animals that became extinct in the past 250 million years. Carefully, he notes the time when each creature lived and when it died. With over 3,500 families on file, it is the most complete record that exists. Intrigued by the cosmic impact idea, Sepkowski begins his analysis. The results are unexpected. The peaks on the graph reveal a whole series of mass extinctions, some large, some small. More remarkably, they are not random extinctions. They seem to occur in regular cycles, every 26 million years. The pattern of extinctions is a complete surprise to Sepkowski and to his colleague, David Raup.
What we saw was that these didn't appear to be randomly arrayed in time, but rather happening, rather regularly. We said it can't be regular. This must be some sort of statistical fluke. How do we go about testing that? Each one of these events is not an entity unto itself, but part of a regular pattern. So if we're going to understand extinction, we've got to understand each and every one of these extinctions, not just one. The second implication is the implication that we can't consider the biosphere as a closed system that has a history independent of not just the Earth, but the Earth's extraplanetary environment. That if we want to understand the history of life, we have to understand the history of the solar system as well.
Do we live on a planet that is devastated every 26 million years? Many scientists doubt that such cyclic extinctions really occur. Back in Berkeley, Louis Alvarez, like many scientists, is skeptical about these results until he mentions them to Rich Muller, a young colleague. Muller begins to think how to explain the regularity.
If the sun had a companion star, and it were in an orbit that were far enough and fat enough that it would be a stable orbit, it would still affect those comets.
Each time Muller suggests a solution, Luis Alvarez promptly knocks it down. Finally, an ingenious theory emerges, one that Alvarez agrees is worth testing. Muller proposes that the Sun has a small dark companion star, which he names Nemesis. Every 26 million years, Nemesis comes close enough to disrupt the Oort cloud, that distant shell of comets at the edge of the solar system.
On the computer screen here, I have a simulation of the solar system. The dark circle there with the bright center represents the Sun. Those small black dots that are orbiting around it like a swarm of bees represent just a few of the many, many comets that are orbiting the Sun. Off there in the distance is that large black dot that represents Nemesis. You'll notice it travels very slowly when it's far from the Sun. It has very little effect on the comets then. But every 26 million years, or on this screen every few seconds, it sweeps around close to the Sun, comes in very close to the comets, it disturbs their orbits and sends a large number of them showering in towards the Earth and the Sun.
Rich Muller's bold ideas are not as bizarre as they appear. The Sun might have a companion, since most of the stars we can see are part of multiple star systems. If Nemesis does exist, it should give us little to fear. It will not be back for 15 million years. Meanwhile, the search for Nemesis is underway at the Leuchner Observatory near Berkeley. While most scientists remain skeptical that the Sun's companion is actually there, Rich Muller and his colleagues are conducting an ambitious survey of the skies.
We're using this telescope in our search for Nemesis. The idea is to take a photograph of a star and then come back and look at it again 6 months later. If it's a nearby star, then the Earth will have moved around the Sun, and the star will look like it's at a slightly different angle than it had been 6 months earlier. We have 5,000 candidate stars. 5,000 stars that have been cataloged, that have been photographed. Any one of those could be Nemesis.
For Richard Muller, this quest provides not merely an unlikely link between the death of the dinosaurs and a dark star. It may illuminate our own human origins, too.
The mammals were around for a long time, but they were never able to take the Earth away from the dinosaurs until the dinosaurs were wiped out. The whole picture that we have of where we came from and where we're going is affected by this. I find it exciting because it's not just physics, it's not just astrophysics. It's biology, it's evolution, it's paleontology. It's a question of why are we here?
The search for Nemesis may be in vain. Scientific attempts to understand the world around us often are. As other researchers develop competing ideas, science moves on. The real meaning of the clay layer, the regularity of the extinctions, and the existence of Nemesis are all hotly debated. From just such conflicts, new truths will emerge. The connection between comets and our own existence may be greater than we thought. These messengers of destruction may too have been the harbingers of life. In the birth of our solar system, countless comets fell to Earth. With them came part of our air, our water, and even the chemicals from which life was to evolve. Our world is made from stardust, and so is the great array of life that flourishes upon it. Evolved from the raw material once born from space, we now return to visit. In faraway and frozen places on Earth, we are finding the evidence of our connection to the cosmos. The remnants of mighty collisions tell us that forces far from home are the very same forces that once shaped our planet, and may indeed have altered the course of evolution. We have visited other worlds and have discovered new wonders about our own. and our journeys have brought us full circle. We have come home from our longest journeys with a fresh sense of wonder for a place called planet Earth.